Hi, this is one of the last FHIR videos, and this is kind of a collection of outstanding questions. We're going to go through a couple different topics. There's bundles, including paging and bulk import and export. There's contained versus reference resources. One quick slide on security for FHIR. Profiling, we're going to talk just a bit more on constraining, extending, and slicing. There were some questions on what is smart on FHIR versus FHIRcast versus CCOW. And then finally, there were a couple of questions on how do I know? And we'll go through those. All right, first topic, FHIR bundle. So it probably won't surprise anyone to know that a bundle is a resource definition. And so it's at the very foundation level of the FHIR resources. And over here, you'll see that it's normalized, which means that it's not going to change anymore going forward. It's defined, it's set. We go take a look inside that FHIR bundle resource, you can see that we have all the typical things like a business identifier, but we also have this next element here, which is called a type, which is really important, which is what are we using this bundle for? A bundle is just a container. So it really doesn't do anything by itself. It just is a container or a wrapper for all sorts of other instances of FHIR resources. So what is this type of bundle for, and what are we going to do with it? Some of the more interesting ones are batch, which we'll talk about when we're importing and exporting, and then search sets. So it also has, a bundle also has things such as timestamps. When was this bundle created? It has other useful elements like total. If you're doing a search, what's the total number of matches in this search response? It has links, which we're going to get to in paging. And links are when you have multiple independent instances of bundles. How do you link those smaller independent instances of bundles together through paging? Well, the answer is going to be a link. And we'll get to that in just a minute. But remember this batch, remember the search set, the total, and the link. Let's go look at some examples. A narrow search. So in this particular example, what I did is you can see this says the link is self. So what link did I use? I used a query to the Happy FHIR server, and I did a narrow search for observations. I only wanted 50 at most, and I gave it a bunch of information with some codes and some other data. So you can see what it returned back was I got a 200, which means everything is good. And I returned back a bundle. The bundle has a server ID of its own. It was updated and created on this date and time. Because it's a search, it's going to give me a type search set. It's going to give me a total, which is that there are 11 observations contained within this particular bundle. And the link it's going to give me is it's just going to give me myself. What did I ask for? And then they'll have all the different observations down here. So you can see it's just a container in the type of a narrow search set where there's only 11 responses. It's just a container or a wrapper around those particular observation instances. Okay, what if we look at a wide open search where there's lots of responses? You can see that our resource type is bundle. We have an ID. It's still a search set. And the link, what I asked for originally is given up here. Give me every observation on the Happy server, of which there's probably 100,000. It's going to give me a relationship to the next one. You'll notice there's no total in here. The Happy server is not going to go out and calculate the total number of observations because it's a lot and it would take a long time. Instead, what it's going to do is going to say, you wanted everything? Okay, I'm going to give you this chunk for now. And oh, by the way, when you want the next chunk, all you're going to do is you're going to get the next independent bundle, which is a different instance of that particular bundle resource, and it'll have its own ID because it's different from this bundle. But rather than saying, go start all over and make the Happy server figure it out again, it's going to say, if you're the client, when the user presses next, just go grab this link right here and send this link to the Happy FHIR server, and you're going to get the next bundle instance or the next chunk of the search set come back to you directly. And that's a huge increase on performance. Let's talk a bit about using a FHIR bundle in a bulk import. All right, the use cases you want to for example, change vendors from a product. And you don't want to have yet another outdated data silo lying around to maintain because it's very expensive, both in terms of hardware as well as resources. And IT resources are very valuable. In terms of CRUDs, this is going to be a create. And just as a word of caution, you better have profiled the daylights out of all this data before starting any type of bulk import. So you better know what your resources are and how you're going to go about the order of importing resources into a FHIR server. Make sure that you avoid garbage in. Always break all of your data up into much smaller bundles. It's easier to manage, especially if you hit an error condition. If you hit an error condition, it's much easier to fix or to update a small chunk than it is to start all over. And you probably have to clean out the database. Things are imported as a bundle resource. So it's going to be a post, but in this case, the type batch, the type or the mode is going to be batch. So it's not a search set type of a bundle, it's a batch. And we're going to post it to the FHIR server. So the endpoint is just the FHIR server address with no parameters, no resource name, no parameters. They'll figure it out when they go and they crunch through this particular bundle, what the resources are. But in case of happy, it's just going to be happy.phir.org/baseR4. That's your endpoint. But the type in the JSON is going to say batch. In advance, before you get into that, you're going to need to know whether or not you're going to do referenced or contained resources. If it's a FHIR server, you should be doing referenced resources because that's kind of the point of FHIR, is that we normalize everything. If you're doing referenced resources, and we'll get into what FHIR and contained is in just a minute, but if you're doing referenced resources, you need to do them in the proper order. For example, all of your institutions and all of your patients need to go in before you put observations into the system. And the reason for that is because you need to know what those IDs are for the patient. There's ways to use medical record number to do it. It's a lot faster, it's a lot better if you are just using the server IDs instead of business identifiers to input data into the, especially for a bulk import into a FHIR server. Other options to not use bulk import via FHIR is that most vendors are going to have the ability to do a direct database import, especially if you're doing massive quantities of data. And so this is another way to do it, but they're going to charge you. And sometimes it gets really expensive, but sometimes the speed and the accuracy is worth it. But again, you have to have everything profiled before you do this. I just want to caution that data import and all the data exchange takes an incredible amount of thought and preparation. Do not ever underestimate what it takes to migrate data from one system to another, even if it's FHIR. Great, let's talk a bit about bulk export. Again, this is probably not going to surprise you. It's done as a bundle. When to do bulk export from one FHIR server to another. Anytime that you want to maintain outdated data silos. It's also done when you're going, from example, from FHIR STU3 to FHIR STU4. So that's an example of maybe you're not switching products, but maybe you're doing an upgrade. And so that's just another thing to keep in mind. In terms of CRUDs, bulk export is search and retrieve, and then you're going to do a bulk import on the other side. Search parameters, keep in mind that there's a search parameter called since, or you can use date ranges. And why do you want to do this on your search parameters? Because you want to break it into smaller bundles. Again, exporting data as much smaller discrete bundles is much easier to manage, especially if you get into an error condition. And typically you're going to start with the most recent data first. For example, if you have data sitting on a server, say you have 3 years worth of data sitting on a server, you're probably going to do the most recent year first and get that into the new FHIR server. And the reason for that is because chances are that clinicians are going to access the most recent data, not something that's 3 years old or 10 years old. They want the most recent data because those are the patients they're still seeing. Data can be exported as XML or JSON as determined by the data information within the request. And another thing to remember is that there's an operation called $export for exporting. I'm sorry, $everything for exporting. And that's one of the operations that you should be very familiar with if you're doing data migrations. Finally, again, it's referenced versus contained resources, and we will continue to talk about this in the next slide. Rather than try and explain it, I'm just going to give you an example. What we have been doing are referenced resources because that's typically what you use when you're interacting with a FHIR server. The most common one is a subject. So I'm in this particular example, I'm in an observation resource, and an observation has a subject. In the subject, I'm going to reference the patient as the type of the resource and a particular identifier for that resource. So this is a referenced resource. There are times that you can't do referenced resources, and then you used contained resources. In this particular example, I'm asking for patient resources back, but I'm also including the $everything operation. So I'm asking for patient resources back. And yet when you go and you look at the response, you'll see that I have all sorts of stuff I'm getting back, including service requests and appointments and episodes of care resources. And I'm getting all of that data so that I don't have to go back and forth with the FHIR server. I'm just getting it all up front. That's called a contained resource. When to use a contained resource. So or I guess I should say first, how to use a contained resource. In addition to the everything operation, there's also search parameters, which you should recognize this table. There's search result parameters in the search documentation in FHIR, and there are query parameters called contained and contained types. You put these right into the API after the ampersand when you're querying for a patient, and you say, by the way, give me everything. Don't just give me the reference. Go interpret the reference and give me all of that data so that I don't have to go back and forth with recursive searches. All right, when do you use a contained resources? You use it if you're no longer going to have access to the FHIR server. Maybe you're on a mobile device. If you're not sure if you're going to have access to the FHIR server, use contained resources. Use contained resources to increase performance on the client. You don't have to do recursive search and retrieves. And do it when the client is able to throw away the results. So what do I mean by that? Maybe the client is going to take the information out of the contained resources and put it up on the screen for the user to see. And then after the user makes the selection, they're going to throw that data away. They're not going to store it again. That's the perfect time to use a contained resource. Another time that you have to use a contained resource is when you're moving out of the FHIR server boundaries. So for example, you're taking a patient record and you're going from one healthcare institution to a different healthcare institution. Then you have to use a contained resource. Do not use a contained resource if you're going to restore or to store that same information that's on the FHIR server, but you decide for whatever reason that your client app decides that they want to store it again locally. Do not do that. That is the entire point of FHIR, is do not duplicate and then have to maintain copies and update copies of the information. That's the entire point of a RESTful services architecture, is that you're always able to go and get that information again, and it only has to be maintained and updated in one place. This is the problem with HL7 version 2 and kind of how we got to FHIR to begin with. Quick note on security. Security is a world unto itself, and it's really a 2-year course or a 30 years of experience in and of itself. I'm only going to do one page on here because honestly, we can't do it justice in this class. For internet security, you're going to inherit the internet security. FHIR, that's the point of FHIR, is to inherit HTTPS security, whether it's OAuth 2 or some other type of LDAP or some other type of security service that's being used by an institution. FHIR can use that. It can also use all the things that we learned different places like the Arizona Cyber Range and on how to harden all the different systems and all the things that we have the knowledge on how to build firewalls, all of these things. Here's 30 years worth of experience right here on this one line. What you need to know though, is that FHIR inherits internet security. That's what you need to know. Role-based access. Role-based access is usually defined at the business level, not at the FHIR level. So at a minimum, the business role-based access is defined within the electronic healthcare record, typically. What you need to know is that FHIR supports these access mechanisms, so long as you profile how you're going to do it in FHIR, whether it's through the metadata of a resource, whether it's through the confidentiality codes, or usually all of the above. You need to know that FHIR supports role-based access. However, it also supports what's called break the glass, or I should say it doesn't disallow breaking the glass, which is a patient comes in 3D, they have VIP status, but they've been in a terrible car accident and you need to know some information about them. There's still ways to go and break the glass, and that's going to be a super user role, and they can break the glass and get whatever information they need. It'll be audited and we'll know who did it, but that's all supported within FHIR. And then finally, auditing. There's several different kinds of auditing. And these are really kind of the security. These are the security up here. I've got them, the security profiles within FHIR. You've got consent, which is patient consent. Typically, a patient is going to electronically consent to on a form. That becomes a consent resource within FHIR. Perhaps it's to send information to a different provider. Perhaps it's to participate in a public health study. Perhaps it's to participate in a research trial. Those are all different types of consent forms, and that's part of security. There's the audit log. Audit logging is this happened, this particular event happened, who, what, when, why, and where, and this is what they did. It's just an event log. It's just this particular thing happened. Provenance, but there are event logs flying around. I can't even fathom the number of event logs flying around, for example, the Johns Hopkins Hospital. I can't even imagine the number on any given day. Provenance is slightly different. Provenance is looking at the same information, but from a different angle. So provenance is looking at a particular instance, perhaps, or set of instances, perhaps a set of patient instances, and who created it, who accessed it, what, when, and where, and why. This is based on the W3C, which is the World Wide Web provenance model. And so FHIR bases FHIR provenance on the World Wide Web model, but it's a way to see who has done what to a particular set of resources or a particular set of instances. And that's called provenance. All right, profiling, constraining, extending, slicing. Again, profiling is to solve a particular use case, a very specific use case. In FHIR, we did talk about this when Dr. Mark Kramer was with us, but in FHIR, there's several different things that you can constrain. You can never do less than is already required by FHIR, but there's not very much required by FHIR, but you can never do less. You can never say make FHIR less restrictive. However, the typical ways to constrain FHIR are you can constrain cardinality. So most things in FHIR are going to say 0 to star or 0 to many. It's not required, and you can have as many as you want. Well, if we're going to constrain cardinality, we can say 1 to many, or we can even say 1 to 1. There must be one, but there shall only be one. We can constrain reference types. For example, a subject can be a patient or a group. Well, in our use case, a subject can only be a patient, or maybe in other use cases, the subject can only be a group. We can constrain value sets, and we can constrain code sets. For example, a particular element must have the value of, for example, status equals draft or status equals final. Or we can use a specific code. We can require a specific code. The system must use LOINC, and it shall use code number 4845-4. So those are examples of constraining a profile. Extending typically involves adding an element to a resource, and that's going to cover probably 90% of the extensions right there, is adding another element to the resource along with its definition of cardinality, reference, or data value set or code set. But if you're going to add an extension to a resource, always start with the extensions library, because chances are it's already defined. You just want to use what's already been defined. As a matter of fact, I would have to think about it, but I don't think that I've ever tried to do something and it wasn't in the extension library. Slicing. I wanted to clarify slicing. What was in the homework example was correct, but after consulting with higher authorities, I just wanted to make sure that I had the definition of slicing a little bit more clear. So slicing is on a subcomponent of a data element. What that means is that a data element can be used in multiple different ways, but we're saying it must either be used this way, either this or this. It must be one of those two, or it can be more. It can be, there's actually no limit on the number of slices on an element, but let's just go look at an example. In an observation, you have an element of code. So for blood pressure, for example, the code must be either systolic or diastolic. It cannot be both, and it cannot be neither. It must be either systolic or diastolic, and it's defined in LOINC. So that's an example of slicing. There are two slices, the systolic slice and the diastolic slice. Let's go slice another data element. Let's look at the cardinality, or let's look at patient identifier. So if we say that there are two types of identifiers required, there can be more, but you have to have at least two. And one slice of the identifier shall be MRN or MR, or the medical record number, and the other slice, which is required, for my hypothetical profile is that it must always have the Social Security number. This is an example of a way that we could slice the patient identifier element. And I've got it down here. I actually copied it right out of US Core for the blood pressure. Here we've got the first code is systolic, the second code is diastolic, and over here we've got the link numbers, the link codes. Right, Smart on FHIR versus FHIRcast versus CCOW. I should have put the acronym up here. CCOW stands for Clinical Context Something Work Group. I believe it was started 2000, 2001, 2002. It's definitely a recognized component of HL7. What does CCOW cover? CCOW covers a single sign-on. Who am I? Do I have authority to do what I want to do? And it also covers context transfer. What am I looking at right now? Am I looking at a particular patient? Am I looking at a particular study? I want to transfer that context to another application so that the other application knows who I am, if I have authorization, what I want to do, where I'm coming from. And I'm also able to audit all of these events. It's based on XML, and I believe it's also based on SOAP. SOAP is a predecessor to HTTP. It was based in XML. It was definitely more error prone and more difficult to work with. You didn't just send it a command and it just worked. There was a lot more things that needed to be fine-tuned between two different applications, like a client and a server. However, it had a lot of good ideas behind it. Then came along Smart on FHIR, or really what came along was Smart Healthcare IT, Smart Health IT. It came along as an idea, like, wouldn't APIs be great for healthcare? It was published, there was an article published in the New England Journal of Medicine in 2009, I believe it was by Boston Children's Hospital, advocating for APIs in healthcare. And that became Smart Health IT, which was funded by the federal government with the intent of pushing API development in healthcare as a way to reduce cost. It became part of the HITECH Act. I believe it actually became part of the CARES Act. And so it became Smart on FHIR. And what Smart on FHIR is it's a way to use government funds to further develop, especially FHIR APIs, to conform with, for example, US Core, and to be able to publish it and to put some of the work behind it to make it a reality. And if you've never spent any time on this website, you should do so, because it's just an interesting read. It also has a list of all the different apps which are supported by different Smart Health IT APIs, and that can be CDS hooks, it can be FHIRcast, it can be FHIR STU2, it can be FHIR STU3, it can be FHIR R4. There's just a long list of all the different things. It's almost a historical perspective, and you can go take a look at the historical perspective. It's got a great chart about the evolution of Smart on FHIR, or just Smart, and see how things have evolved since 2009. It's kind of fascinating, to be honest. Finally, FHIRcast. In my mind, FHIRcast I always think of FHIRcast as CCOW for FHIR. So what FHIRcast does is it's a way to transfer the single sign-on, who am I, do I have authorization, as well as the context, what patient am I looking at, what study am I looking at, and create all the necessary audit logs to know that transfer has been successfully completed or not. And there's also status and some other things. FHIRcast typically works with JSON, but I believe XML is an option. I'm quite certain it is. If you would like to take a look at FHIRcast in the real world and working, go take a look at the RSNA Imaging AI in Practice videos at the time when the radiologist is looking at a DICOM imaging study and they click the Create Report button, what is actually being transferred via FHIRcast. So it's not part of the FHIR standard itself. It's an application which is meant to work directly with all the FHIR resources. But what FHIRcast does in that particular example is it'll tell the reporting application who the radiologist is. It'll verify, the reporting application can verify that they have permission or authority, the correct role to create a radiology report. It will tell them who the patient is, what the study instance UID is, and what the procedure name is, so that the reporting application can launch the correct type of radiology report. For example, if it's a CT study, you don't want an ultrasound template. You probably want a CT abdomen template for the radiology report. And so that's what FHIRcast gives you. FHIRcast is incredibly powerful because it allows you to cascade APIs in healthcare. So that's something that you probably want to take some time and learn more about. All right, finally, how do I know? So some of the questions were, how do I know which diagnosis or condition is the most important? How do I know why the person came into ED? How do I know why the person was admitted? You're probably going to already figure out that we're going to go back to resources and take a look at some of the FHIR resources to answer these questions. But as a side note, the FHIR two things need to happen. Number one, the data needs to be in the resources, so it better have been profiled correctly so that your data is there when you need it. The second thing is that your user interface on the product has to display the correct data that you need. It can be in the resource, but if they don't display those elements that the user needs, it doesn't matter if it's in the database if you can't see it. The other thing is that the user interface needs to order things correctly, being the highest priority first. If the patient has a list of 20 conditions and the important ones that you need to know about are at the bottom, it's going to be hard for you to find the information. So that's just something for you to think about, is not only do you need to be able to know that the data exists, that you can obtain it, that it's just going to be displayed, but that it's ordered correctly. So these are the kinds of questions that you need to be asking your client application as they come in the door to sell you something new. Let's go take a look at the resources. Encounter, which is like a visit, and a condition. Let's go look at these two resources. How do I know which is the diagnosis or condition is the most important? This is the condition resource that we're looking at right now, and let's take a peek at it. Some of the important elements. Here we have a clinical status. The clinical status is active, or maybe it's inactive. If it's inactive, that is kind of infers a priority, right? Or if it's in remission, you probably want to look, or resolved, you probably want to look at the active conditions first. So that's probably a sort parameter, if not the default sort parameter on your user interface. Category, is this a problem list, or is this a particular visit or encounter diagnosis? Probably something that should be displayed. Severity, I put the severities up here so you wouldn't have to go click on them. The severities are defined in FHIR, these are SNOMED codes, as severe, moderate, or mild. If I were creating a user interface, personally, I would at least give the user the option to sort based on severity, and I'd probably default it to sorting on things that are severe in combination with things that are active. Another thing that we have here is code. Here's the identification for the code or the problem diagnosis. This is what you really want to know about. What is the actual code? It's probably SNOMED. What is the actual code? Why was this? What is the condition? Is the condition a broken bone? Is the condition diabetes? There's gosh, 40,000 conditions defined in SNOMED. I'm not sure if that's quite the right number, but it's a lot. And so this is something that obviously you're going to need to display. Now, how do I know which is the most important condition? If the severity and the clinical status are the same, and there's multiple codes, so there's multiple conditions, but they're all considered to be severe, I think at some point, this is where clinical knowledge comes into play. And hopefully there's not more than we can display on one page on the user interface, but this is, I'm not sure how to answer that question. Once we've sorted on things that are active and severe, if there's still a long list, I'm not sure how to answer the question. Other than I think clinical knowledge has to come into play at some point. Maybe perhaps we have onset date down here. So maybe perhaps we can also, in an attempt to order and sort this list for you to be more useful, perhaps we can look at onset date and time, and perhaps we can look at abatement date and time to see if these are things that are useful in sorting lists. Actually, I'd love to continue that discussion and see if there's other things within this particular condition resource that you would think would be useful in terms of sorting to create an ordered list so that the highest condition or the most important condition is at the absolute top. How do I know why the person came into ED or why they were admitted? All right, so now we're looking at an encounter resource. Let's take a look at some of the more interesting elements in here. Okay, we've got a status. The status of this encounter was planned, arrived, triaged, in progress, on leave, finished. So this might be useful information, is what is the status of it? What is the class? And I put some of these value sets up here for you so that you could see without clicking around too many times. So what is a class? A class in an encounter is it ambulatory, emergency, home health, acute? So this information is probably useful when sorting information or ordering information for display on a user interface. But again, you have to make sure that the user interface, that data is in there, and that it was profiled, and that the user interface is capable of displaying it, and probably it's capable of sorting on it. Down here we have type. Type is the different types of encounters, but probably something that we're more likely to go look at is the service type. Service type up here is why were they in the first place? There's all different types of service types, which are defined as part of HL7. And so, genetic counseling, is that the same priority as some of the other things? Perhaps like one of the mental health counseling? Probably not, or possibly not, but maybe this is another way to ascertain why the person was admitted, is to take a look at the service type. And then we also have, in an encounter, we have priority. The priority codes which are defined for this resource are coming out of HL7 version 3, and they're as soon as possible. There's other things like emergency. There's other things down here, such as routine. So you can see the way that these are defined, and I have to admit that I don't always agree with how logical the way that things are defined in HL7, but at this point it is what it is. How can there be something higher than as soon as possible? I don't know, but there is. So you can take a look at these listed priorities, and again, it's something that you want to go through and make sure that you're able to see on the user interface as well as sort on. I'm still in the encounter resource here, and other things that you're going to want to know about, like, for example, why was the person coming in through ED or admitted? There's a reason code, the coded reason why this encounter takes place. So chances are that there's probably something useful in here. Here's examples of reasons. And this list is huge. And so I just kind of pulled something right out of the middle. Insect bite, non-venomous, of the foot, infected. Okay, that's a really specific reason. Not all of them are quite that specific. Perhaps that rather than having a reference code in here, it actually goes back to a different, we can reference back. This is a referenced resource to a condition, a procedure, or an observation. Perhaps there's some information in the diagnosis element. If you want to know why the patient was admitted, we can come down here. There's more information in a encounter resource for hospitalization. We know who admitted them, why, where they were admitted, and all sorts of other information. So really, again, it comes down to profiling and making sure that the information that you want to answer these kinds of clinical questions. So here's your use case up here. This is a use case that you need to profile. This is a use case that you need to profile. So you know that the data is in there, it's using the correct code set, you know that you can access it. And then when you're purchasing client applications, you know exactly which data that client has to be able to display. Usually it's configurable, but you have to know which exact data that you want that client to display to be able to answer the questions for your use case. And on that note, I'm going to wrap this up. Thank you.